Hello students, welcome to my YouTube channel. In this video lecture, we are going to solve further 10 questions from Great Circle chapters in 𝐃𝐞𝐿's General Navigation book. So let's begin with question number 71. Aircraft is at position 60° north, 5° west. It tracks 090, that means easterly direction, for 350 kilometers. On completion of the flight, what will be its destination? So we are at 5° west. The latitude of both the positions is the same. So this is your prime meridian, 0°. This is your 60° north, 5° west, right? So 5° west is here, point A, and we are traveling to point B. Now point B can be in the western hemisphere itself, or it can be in a complete different hemisphere, that is eastern hemisphere. Let's look at the D long. By looking at the D long, we'll come to know the position A longitude is 5° west, pretty close to the prime meridian. Now drumline distance is D long in minutes into cos of lat. So 350 kilometers. 350 kilometers is nothing but 350 divided by 1.85, 189 nautical miles, divided by cos 60, which is equal to D long in minutes. So 189 divided by cos 60 is 378 minutes. 378 minutes divided by 60 is 6 degree 18 minutes. 6 degree 18 minutes. Okay. So now the difference between prime meridian and 5° west is the D long here is 5 degrees. The D long that we have got is 6 degree 18 minutes. That means out of this 6 degree 18 minutes, you are going to travel 5° longitudes in the western hemisphere, reach prime meridian, and additional or remaining 1 degree 18 minutes will be traveled in the eastern hemisphere. So your new longitude, that is at Bravo is at what longitude? Bravo is here at longitude 1 degree 18 minutes east. So what is the longitude of Bravo? 1 degree 18 minutes east. This longitude. Okay. 72. Waypoint 1 is 60 north 50 west. Waypoint 2 60 north 20 west. What is aircraft latitude after passing 35° west? So draw this. So A, 60 north 50 west. Bravo, 50 north and 20 west. 35 west longitude will be right in the center, right between these two longitudes. 50 west, sorry, 20 west. So north, since it's the north hemisphere, your great circle is going to pass like this through the nearest north pole. Now the distance between these two longitudes, 50 west and 20 west, is departure or drumline distance. Next point, or the next step, draw a triangle like this. Okay. Now this triangle, this side of the triangle will divide the complete convergency angle between your great circle and drumline into two parts. So the inside part will be half of convergency angle. The outside part will also be half of convergency angle. We are not concerned about the outside part, so ignore it. This distance will be equal to half of departure. Half of departure. This distance is great circle distance. Okay, so step 1, find departure. Departure, which is equal to Ramline distance, is d long in minutes into cos lat. Now d long between 20 west and 50 west is 30 degree. So 30 into 60 into cos 60. 30 into 60 into cos 60 is 900 nautical miles, right? So if departure is 900 nautical miles, half of departure will be 900 ka half 450 nautical miles. Okay, so we have got the measurement of this side of the triangle 450. Now let's find convergency, which is d long in degrees into sine latitude. What is d long in degrees here? It is 50 and 20, 30 degrees. Sine 60. 30 into sine 60 is 25 degree 58 minutes, or approximately 26 degree. Convergency angle will be half of that, half of 26, 13, and convergency angle ka bhi half will be 13 ka half, that is 6.5 degrees. So now we have a triangle whose measurements are equal to 450 and 6.5. Now let's apply tan theta formula. Tan theta, or tan of 6.5 degree, opposite side great circle distance, adjacent side 450 nautical miles. So great circle distance will be 450 multiplied by tan 6.5. So tan 6.5 into 450 is 51.27 nautical miles, or approximately 51 nautical miles. Okay. Now we all know that 1 minute of latitude is equal to 1 nautical mile. So 51 nautical miles will be equal to 51 minutes of latitude. 51 minutes of latitude. So this is your 60-degree north latitude. When you travel 51 minutes to the north pole, towards the north pole, the new latitude will be equal to 60 degree 51 minutes north. 60 degree 51 minutes north. Next. A Lambert's chart whose constant of the cone is 0.8. Constant of the cone is another term for sine latitude. So sine latitude ka value they have given us directly 0.8. A straight line joining points A and points B. Now great circle at A is 0.75. Great circle at B is 0.95. The difference between two great circle tracks is equal to convergency, and here the convergency is 20 degree. Okay, so what is the longitude of B? Let's find out convergency. Let's use convergency formula. D long in degrees into sine of latitude. So 20 degree divided by sine latitude is 0.8. So 20 divided by 0.8 is 25. Okay, it is 25 degrees. Now A, in order to go from A to B, you have to fly 0.75 degrees. Northeast direction, that means alpha is here. Bravo is to the northeast of A. Okay, now what is the longitude of A? It is 4 degree west. So longitude of B will be different from longitude of A by a value of 25 degree. So we have this representation of the earth. 0 degree prime meridian, 4 degree west. So new longitude will be what? D long is 25. So this is 4 degree. Here the D long is 4 degree. Remaining 21 degree will be in the eastern hemisphere. So your destination will be 21 degree east longitude. 21 degree east longitude. Aircraft is flying with the aid of INS system. The following 2 points have been entered. Waypoint 1, waypoint 2. When you are passing 025 degree west longitude, what will be the latitude shown on the display? So it's similar to the previous question. Let's draw it. We are in the north hemisphere. 60 north, 40 west and 10 west. 40 west will be here, 10 west will be here. Plotting is must be done correctly. Next, great circle track. Now the distance between these two longitudes is your departure is equal to departure. To find the latitude at 25 degree west longitude. Now 25 degree west longitude is right between it's right between 40 degree west longitude and 10 degree west longitude. Okay. Now next step, let's draw a triangle here. Let's label it. This will be equal to half of departure, and this will be your great circle distance. This will be half of convergency angle. Step 1, what is departure? D long in minutes into cos of lat. So D long 40 minus 10 30 degree into 10 minutes into cos of 60, 150 nautical miles. Now half of this departure will be equal to 150 by 2 is 75. Step number 2, convergency. D long in degrees into sine of lat. So D long is 30 degrees, sine of 60. So 30 into sine 60 is 26 degree approximately. Convergency angle 13. Half of that also will be equal to 6.5 degrees. So now we have this values. Let's fill them here. 75 and 6.5. Now apply tan theta formula. Tan of 6.5 equals to great circle distance divided by 75 miles. So great circle distance is 75 into tan 6.5. That is equal to 8.5 nautical miles. Now we all know that 1 minute of latitude equals to 1 nautical mile. So 8.5 nautical miles will be equal to 8.5 minutes of latitude. So our final position here, the latitude will be equal to 60 degree 8.5 minutes north. The departure between two positions is given. What is the longitude of second position? Now both are located on the same latitudes. Drumline distance equals to d long in minutes into cos lat. Is equal to 40 degrees. Okay, that is equal to 40 degrees. D long is 40 degrees. Now, one position is, let's draw this. First position is 100 degree east. So 100 degree east is this, let's say. Now the second position can be to the east of this longitude or it can be to the west of it. So there are two possibilities. Now the D long is 40 degree. So if the second position is 40 degree to the east of initial position, so our new longitude might be 100 plus 40. So that is 140 degree east longitude, or it can be less than 100 degree. It can be to the west of 100 degree east. So 100 minus 40 is 60 degree 060 degree east longitude. So either 060 degree east or 140 degree east longitude. The autopilot is coupled to INS. You're flying from one waypoint to another to the next one. What is the track change at waypoint number 2? So 60 north all the way, 40 degree west, 30 degree west, 20 degree west. We are in the north hemisphere, so great circle track will be like this. The great circle track at A, B, C. Okay. So, as we go from alpha to Charlie, the rumline track will be the constant. It will be a constant rumline track of 0, 0. This is your north pole, let's say. So rumline track at A 0, 0. So great circle track at A will be rumline track minus convergency angle, because great circle is above the rumline track. Okay. So this big angle is rumline. Great circle is this small angle only. So in order to get that small angle, you will have to subtract convergency angle from this big angle. Now what is convergency here? D long, 40 minus 30 is 10 degree. Sin lat, sin 60. So sin 60 into 10, 8 degree 39 minutes. So approximately 9 degree. Okay? So 0, 0 minus 9 is 081. So great circle at A is 081. Great circle at B will be equal to, it will be great circle at A plus convergency. Correction. This is convergency angle, right? So convergency is 9 degrees. So convergency angle will be 4.5. So 090 minus 4.5. So that is 90 minus 4 is 86 and 85.5. So great circle at A plus convergency. Why? Follow the DIID diagram. What is the DIID diagram? It says that if you are in the northern hemisphere and you travel easterly direction, the great circle track will increase. If you are in the north hemisphere and you travel easterly, the great circle track will increase. So now we are in the north hemisphere and we are traveling towards east. So great circle track at B will be more than the initial great circle track. So 85.5 plus convergency 9 degree. So 85.5, that is 94.5 or approximately 95, whatever. Now great circle track at C. Again same concept, it will be more than great circle track at B by convergency. Convergency is the angle between two different great circle tracks. So by convergency. So 94.5 plus 9 degree. So 103.5 degrees. So what is the change at this position, at the second position? The change, what is the difference? The difference is equivalent to 9 degree. So the change that is happening at position Bravo, the second position, is minus 9 degree. So what is the approximate track change on passing waypoint to minus 9 degree? Because it is less than great circle track at sea. Aircraft is coupled to position 1 and position 2. What is the latitude shown when aircraft passes 45 degree west? Okay, 45 degree west. So first position is 60 north. So we are in the north hemisphere, fine. 60 west, 30 west. This is the great circle track. 45 west is right between 30 west and 60 west. Make a triangle. Now the distance between these two longitudes is equal to departure. Distance between these two latitudes is great circle distance. This angle is equal to half of convergence angle. This distance is half of departure only up to this point. Step 1, find the departure d long in minutes into cos of lat. So 60 west, 30 west, 30 degree into 60 minutes into cos of 60. So departure equals to 30 into 60 into cos 60, 900 nautical miles. Half of 900 is 450 nautical miles. Convergence is d long in degrees into sine of latitude. D long is 30 degrees, sine of 60. 30 into sine 60 is 26 degrees. Convergence angle is 13 degree. Half of that will be equal to 6.5 degrees. So let's write these values in the diagram, or let's label the diagram. Departure 450, half of convergence angle 6.5. Now tan of 6.5 equals to great circle distance divided by 450. Great circle distance is 450 miles into tan of 6.5. Now tan 6.5 into 450 is 51 nautical miles. Now 1 minute of latitude equals to 1 minute is 1 nautical mile. So 51 miles will be equal to 51 minutes. So this latitude will be equal to 60 degree 51 minutes north. Next. Departure is given. What is the longitude? So 1200 miles divided by cos 60 equals to d long. Formula from line distance. So 1200 divided by cos 60 is 2400 minutes divided by 60 again, that is equal to 40 degree. So now initial position is 90 east. 90 degree east. If this is your prime meridian and this is your initial position 90 east, the second position, your destination can be to the east of this. If it is to the east of it, we will have to add the d long. So 90 plus 40, which is 130 east. If it's to the west of it, we will have to subtract the d long. So 90 minus 40 is 50 degree. So 050 east. So there are two possibilities, either 130 east or 050 east. Next, 1800, similar question. Divide by cos 60 equals to d long in minutes. So 3600 minutes divided by 60 is 60 degree. Now your original position is 160 east. very close to the anti-meridian. So now you will draw a different diagram, a diagram of the representation of the earth from the north pole. So this is your north pole, prime meridian, 180 east, west meridian, 90 east. The first initial position is 160 east. Now there are two possibilities. If the destination is to the east of 160 east, our destination will be, this is 20 degree. Total D long is what? 60 degree. So 60 will be divided into 20 and 40, two parts, 20 degree and 40 degree. So 20 degree will be in the eastern hemisphere, remaining 40 degree will be traveled in the western hemisphere. So this will be 140 west. 180 minus 40 is 140 west. This is if your destination is to your east. Okay, easterly directions are anti-clockwise. Now if your destination is to your west, so westerly directions are clockwise. So your destination will be somewhere here. Now initial location is 160 east. What is the D long? D long is equal to 60 degree. So your destination will be 160 minus 60, which is 100. So 100 east. So your destination can either be 100 degree east or 140 degree west. So select that option which has either of these values or both the values. Aircraft is connected to its inertial system. It flies from A to B. What is the course of aircraft when it arrives at B? Great circle at B. 50 south, 10 west, 50 south, 30 west. Same latitude. We are in the south hemisphere, so great circle will be like this. Okay. A, B. Rum line at A, 270. You're going from A to B, so 270. Great circle at A will be rum line at A minus convergency angle. 270 minus convergency angle. What is convergency? D long, 30 west, 10 west, 20 degree into sine of 50. That is 15 degree 19 minutes, or approximately 15 degree, let's say. So convergency angle is 7.5. So rum line, great circle at A is 270 minus 7.5. 262.5. Great circle at B will be different from great circle at A by an amount of convergency. Now whether it will be more than that or less than that, follow DIID diagram. So DIID diagram states that if you are in the south hemisphere and you travel westerly, the great circle track will increase. You're traveling towards the west, right? A to B, westerly direction. So great circle track will increase. So the great circle track at Bravo will be more than great circle track of A by a value of convergency. So 262.5 plus 7.5 is 270. So great circle track at B is 270. So we'll stop here. I hope you have understood all the 10 questions I have done in this video lecture. All the 10 questions were pretty long and it involved using formulae, substituting the values in them, drawing diagrams. So it takes a bit more time than compared to other questions. But be patient. Whenever you're solving these questions of great circle, drum lines, convergencies, make sure you draw the diagrams, you write the formulae, put the values correctly, check them, recheck them again, and be slow and steady. Don't be very fast, otherwise you can put wrong values in wrong places. and as a result the whole process or the whole answer solution gets wrong. So be slow and steady when solving these questions. Apart from that, in my next video lecture, I'm going to solve the next 10 questions. So don't miss that. I'll see you there.